The screen is divided into two parts. A right side shows the system status screen, which displays the number of stored file chunks, the operation of the consensus protocol, and the map, showing location of chunks in the network. Data is collected in real time from the NeoFS nodes. The console application for working with the system is open at the left. At the first stage, using the console application, we are creating a container with a storage policy in 3 copies in different countries. In this case, you can specify any placement rule using query language. For example, to store data on nodes that have SSD disk in 4 countries, one of which has to be in the US, another one is in Europe, and 2 in any other regions. Or to declare data storage only in your own country, if it is required by your legislation. When the container is created, we will upload text file. The placement of the file corresponds to declared storage policy for the container and is displayed on the map. Our system provides a convenient interface for developing client applications. Any developer can make any interaction he needs with NeoFS in his app or dApp. Create any application, be it a photo gallery, a video service, or a POSIX-Lite pseudo-file system. We will show this with an example of a client UI integrated with the Neo Wallet. We are using a graphical application. After entering the Neo Wallet, we can look at the status of the wallet and NeoFS account. Let's transfer some amount of gas from the Neo Wallet as a deposit for data storage in NeoFS and confirm the transaction, and wait for the transaction to appear in the Neo blockchain. After the transaction was accepted by the Neo blockchain, we see that the transferred amount of gas has been credited to our NeoFS balance. In the storage section, we see the container previously created in the console application. It contains the uploaded text file. We are creating a new container with a storage policy of 3 copies of the file in different countries with a capacity of 6 nodes. Let's upload a video file to the created container. The map displays the nodes that have received chunks of the stored file. We can see that chunks of the video file are uniformly distributed over the container nodes without any additional requests to the nodes. Thus, the problem of network balancing is solved, due to the representation of the network map in the form of a graph and the consistent result of placement functions. Let's upload another file and open both of them by downloading from the system.
Эй, придержи лифт! Я тебе это припомню. Какой твой номер? 111.
Now we are removing the video file. As you can see on the graph, the number of chunks in the system has decreased. We will demonstrate how data audit works in NeoFS. We previously uploaded data to the system by creating 15 storage groups. Storage group is a logical validation entity that aggregates a big amount of data from one user. Any number of storage groups can be created within one container. The system audits storage group for proper storage, and payment is made based on the result of the audit for the entire storage group, and not for individual files. For demonstration, we are initiating audit from the command line. On the histogram, you can see a successful audit result. Let's corrupt the operation of one of the system nodes and initiate audit again. We will make sure that not all groups have passed the audit, and therefore the storage nodes won't receive payment. It motivates storage nodes to maintain the consistency of the stored data. Let's consider again the system with preloaded data. We will deliberately violate the policy of storing a part of the data in the system, corrupting the data stored by one of the nodes. 124 chunks have been stored on this node. We are initializing data replication on all the remaining nodes and see that they will perform 124 data replication operations by copying exactly those chunks that they were corrupted, restoring the storage policy. In a real system, this operation is asynchronous, and nodes of the system are engaged in self-regulation independently in the work process. NeoFS network map is formed by the nodes of inner ring once an epoch. When changing the network map, the storage node's configuration of some containers may change, which will require data migration. Due to the mechanisms of container formation and data placement, only containers with new nodes will be migrated. The rest of the network will remain unchanged. We are adding a new node to the network to initiate the migration. We can see that about 10% of all chunks have migrated, which is correlated with the network size change. Thank you for your attention.